Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will learn how to calculate the area of a solid of revolution. To do, for this, there is two formula. Let's take two function, x equal f of x, and I want to rotate it around a and b, and y equal g of y, and rotate it around c and d. And I will give you the formula if I want to rotate around the x-axis or if I want to rotate around the y-axis, and at the end we will do an exercise. So if I'm spinning f of x, so this is the x-axis. If I'm spinning f of x around the x-axis, the formula would be area is equal sum between a and b, because I'm spinning between a and b, of 2 pi f of x square root of 1 plus dy over dx, which is the derivative of y according to x, square times dx. But if I'm spinning f of x around the y-axis, this is the y-axis, there is another formula, which is the area is equal between a and b of 2 pi x square root of 1 plus dy over dx square times dx. Yeah? Now, if I'm spinning g of y, so if I have a function like x equal f of x and rotate it around the x-axis, those are the formula. And if I'm spinning g of y around the x-axis, and now between c and d, so that's my x-axis and this is g of y, and the formula would be the area is equal between c and d of 2 pi y square root of 1 plus dx over dy times dy, and this is square. And if I'm spinning g of y around the y-axis, so this is the y-axis and I'm spinning like that, g of y, the formula would be a is equal integral between c and d of 2 pi g of y times square root of 1 plus dx over dy square times dy. You will understand better if we do an exercise. So let's do an exercise. So these are the formulas. Let's do an exercise here. I will take a formula, f of x is equal to 2 square root of x, and I want to spin it around the x-axis. So I want to spin it around the x-axis, and I want to study the area between 3 and 15. Yeah? So I know the area. The formula of the area is equal between 3 and 15 of, let's do it here, it's 2 pi f of x and the square root of 1 plus, that's the one. It's going to be this formula that I will be using. So it is 2 pi f of x square root of 1 plus d of y divided by d of x square dx. That's it. So now the 2 pi is a constant. I can take it out outside my integral, and I will replace f of x by its value, which is 2 square root of x. So the area is equal to 2 pi between 3 and 5, and f of x, I replace it by 2 square root of x. This is 5, yeah? 1 plus, well, d of y over dx square. If I have f of x is equal to 2 square times x to the power 1/2, so the derivative f prime of x is equal to, it stays, and times 1/2 times x to the power minus 1/2. If you remember the derivative, I will deduct 1 from the 1/2, and I will divide it by no, I will deduct 1 by the 1/2. I don't have to divide it. I'll bring the 1/2 besides the 2, and I will deduct 1 from the 1/2. So this 2 divided by 2, it's equal to 1. 1 times 1 is 1. So f prime of x is equal 1 divided by square root of x. So here it becomes dy over dx, 1 divided by square root of x, but square dx. So this here does not belong to the solution. This is how to do the derivative. Okay? So now 1 divided by square root of x square, it is 1 square divided by square root of x square, which is, it will become 1 divided by x. So the 2 here is a constant. I will take it outside my integral. The area will become 4 pi between 3 and 5 square root of x, and then, as we said, 1 plus 1 divided by x, but here I want to do common denominator, so 1 times x is x plus 1 divided by x dx. But here I have square root of x here and square root of x here, because I can write it a equal 4 pi 3 divided by 5 of square root of x times square root of x plus 1 divided by square root of x dx, and this would disappear. I would end up by square root of x plus 1. So I say let u equal square root of x, no, not square root, let u equal x plus 1, so my du equal dx. And if I want to study the boundary of my integral, I replace x by 1 in u, x by 3, and then next time I will replace x by 5. So u equal 3 plus 1 equal to 4, or u equal 5 plus 1 equal to 6. So my area is equal 4 pi between 4 to 6 and u to the power 1/2 du. And the integral of u to the power 1/2, this is equal 4 pi u to the power 3 over 2, because 1/2 plus 1 is 3 over 2, divided by 3 over 2 between 4 and 6. So the area is equal 4 pi times 2 over 3 square root of u to the power of 3 between 4 and 6. So this become 8 pi over 3 times square root of 6 to the power of 3 minus square root of 4 to the power of 3, whatever is the answer. I think if you do it, it become equal to 469.14, because it's an area u square. Now we spin it around the x-axis. I will take another formula, and I will spin another function, and I will spin it around the y-axis. So let's start it on new page. Let's take the formula f of x is equal 1/2 x square, and I want to study it between 0 and square root of 3. So the area of a solid revolution would become a equal 2 pi, because I'm between 0 and 3, 2 pi should be inside. I wrote it inside here, but like 2 pi is a constant, I can always take it outside my I can take it outside my integral, because it's always going to be a constant. So it becomes 2 pi between 0 and 3. X, the formula is x here. Actually, I was talking about this. So that's the formula that I'm using because it's an f of x. So the 2 pi goes outside and it's x square root of 1 plus dy over dx square. So x square root of 1 plus dy over dx square, and I will multiply it by dx. And now I have f of x equal 1/2 x squared, so f prime of x is equal 1/2 times 2x, so this and this would disappear, so f prime of x is equal x, so dy over dx is equal to x, so my area become 2 pi times x square root 2 pi times x square root of 1 plus x square, because I have the square here, dx. So here I say let u equal 1 plus x square and my du equal 2x dx. So my x dx is equal du divided by 2. So now my area become, and because I put u, I have to study the boundaries again. So u equal 1 plus 0 square, it's equal to 1, or u equal 1 plus 3 square is equal to 10. So between 1 and 10 here it become, actually it was square root of 3. We said square root of 3. So yeah, so the 0 becomes the same, and square root of 3 square is 3. 1 plus 3 is 4. So here it becomes 4. And I will keep the 2 pi outside. Well, du divided by 2, I can put the divided by 2 outside and the du here, and it will become x dx is the du divided by 2, and it will become square root of u du. And that's become easy. So area between 1 and 4 of pi outside of u to the power 1/2 du. So it become u to the power 3 over 2, because 1/2 plus 1 is 3 over 2 divided by 3 over 2 between 1 and 4. So it become square root of u to the power of 3 times 2 over 3 between 1 and 4, and the first time I replace my u by 4, so it is equal 2 over 3 times square root of 4 to the power of 3 minus square root of 1 to the power of 3 is 1. So that would be it. And if you do your calculation, it become 14.66 u square. Let's put it here, is equal 14.66 u square. To finish my explanation, I will do an example using this formula, the one that I did it by mistake, which is this. When I have x is equal of f of x, something like that. Yeah, when I have x is equal of f of x, here we use the formula where y equal f of x or g of x. I will use a formula where f of equal g of y, x is equal g of y. This is x, should be here. X is equal g of y. So let's take an example. Let's take the example of x is equal 1/3 of y to the power of 3. and I want to rotate it around the y-axis, and I will study it between 0 and 1. So again, the area is equal 2 pi, let's see it here. That's it. I will use this formula. I'm rotating around the y-axis. Pi between 0 and 1 of x square root of 1 plus dx over dy multiplied by dy, and this is square. I will use this formula. And now here my x is equal 1/3 of dy, so the area will become 2 pi between 0 and 1, and I replace my x with 1/3 y to the power of 3 square root of 1, and this is according to dy, and 1 plus dx over dy, so I will derive 1/3 y3 prime. It become 1/3 of first times 3y2. So this and this would disappear. The derivative, it become y2 square. So y to the power of 2 square dy. I will erase this because it's confusing. So this is, I showed you how I calculate my derivative. So the area is equal 2 over 3. The 1/3, I'll take it outside because it's a constant. Pi between 0 and 1 y3 square root of 1 plus y to the power of 4 dy. And now I let u equal 1 plus y to the power of 4, and my du is equal 4 y to the power of 3 dy. And here I realize I have y to the power of 3 dy, so my y to the power of 3 dy equal 1 over 4 du. So when I want to replace du, I will put 1 over 4 outside. So my area become 2 over 3 pi, and integral, we did not calculate the boundary, but we will do it. If I want to put du here, so I have to multiply it by 1 over 4. And y3 dy become 1 over 4 du, and then this is square root of u. Okay, so now I can simplify this 2 and this 4 become 2, so it become 3 times 2 is 6, 6 pi, or pi over 6, u to the power 1/2, and it was between 0 and 1 when I had y, so now when I have u, it will become 1 plus 0 to the power of 4, it's equal to 1, so this is 1, and then 1 plus 1 to the power of 4, it is equal to 2. So between 1 and 2 now. It become of du, so it's equal pi over 6, y to the power 3 over 2, divided by 3 over 2, because 1/2 plus 1 is 3 over 2, between 1 and 2, so my area become 2 divided by 3 times pi divided by 6, square root of u to the power of 3 between 1 and 2, and let's do the calculation now. This and this becomes 3 here, and then pi divided by 9, square root of 2 to the power of 3 minus square root of 1 to the power of 3, which is 1. So it is equal pi over 9 2 square root of 2 minus 1. And if you do the calculation here, it becomes equal to 0.64 u square. I hope that you like this video. If you like the video, please subscribe to my channel, and if you put like, I would really appreciate it. Thank you for listening.